Today's Daily Dose of Math is about Principles 1, 2, and 3 for both the MTH-4153 and MTH-4273 geometry courses. Both of these courses have a list of principles that are attached to the student's exam, which is an advantage because when the student is using one of the principles as part of their steps in their math, when it comes time to justify what they have done, instead of having to write out one of these long sentences, the student is able to say, I used principle 2, or I used principle 3. There are not only 3 principles in the course, but these are the 3 that have to do with judging whether 2 triangles are congruent. Principle 1 says, if the corresponding sides of 2 triangles are congruent, then the triangles are congruent. And that isn't that hard to read or to write, but also it is the same thing as what I used to call in other courses I've taught, the SSS rule. It means side, side, side. Principle 2 says if 2 sides and the contained angle are congruent to the corresponding 2 sides and contained angle of another triangle, then the triangles are congruent. That used to be referred to in my old course as the SAS rule, side, angle, side. Principle 3 says if 2 angles and the contained side of one triangle are congruent to the corresponding 2 angles and contained side of another triangle, then the triangles are congruent. And that is the old ASA rule, angle, side, angle. When the student uses one of these in a situation in their exam, they're allowed to justify their work simply by saying, I used principle 2 or I used principle 1, whichever one applies. So it saves them a lot of time. There are many different scenarios where this can be tested. You have a lot of combinations of what can happen. You have 3 rules for congruency, but for each there could be a yes answer or a no answer. And when you have a no answer especially, there can be different reasons for why it's a no answer. The principles have details, and it's possible for a situation to seem to be obeying parts of the details of the principle, but to be disobeying a different part. So therefore there's more than one possible way in which the situation can violate the rule and give you a no answer. Trying to think of all the different scenarios seems like too much to the student. It makes it feel like to the student that they are being asked to know a dozen different things. And that is the advantage of learning by using these principles instead. Because if you are familiar with these 3 principles of congruency, and if you have practiced with each of them a little bit, you get a feeling for how they work. And then when you're in a situation, perhaps in an exam where you need one of them, you're able to figure out which one applies and then apply it. So you just have to be able to know how to use these and to be able to adapt to the situation. And then it seems like there's a lot less work to do. There are only 3 principles to know about for congruency. Here I have 3 pretty simple examples, one for each. In this one we have 2 triangles. Each of them are right triangles, and their side lengths in both cases are 6, 8, and 10. We're asked, are they congruent? And the answer is yes. And my justification is principle 1. And I can just write the number 1, put a circle around it to make sure that the teacher correcting the exam notices it. I have justified my answer of yes by applying principle 1. In question 2, we have sides of 80 and 75 in both triangles, and in both cases the angle in between those 2 sides is 33 degrees. This is another yes. And this is obeying everything that is described in principle 2. So my justification is to say I used principle 2. Be careful, because one of the details that matters here is that the angle we're dealing with has to be in between, contained, as it says in the principle, between the sides that we're dealing with. That brings us to example 3. Here we have a triangle with a 100-degree angle and a 44-degree angle, and the side in between is 4 units in length. And here we have a 100-degree angle and a 44-degree angle, and the side in between is 5 units in length. In this case, my answer is a no. And my justification is I'm applying principle 3. Because principle 3 says that these 2 angles have to be equal, and they are, so we're good with that detail. But the sides in between the angles, the contained sides, have to also be equal. 4 is not equal to 5, So the answer is no. And if I want to go into more detail, I can say 4 is not equal to 5 to explain why I think it violates principle 3. Remember, if you're using this same type of math, if you're learning the same principles in a different course than these two courses, from a different curriculum than where I teach, you may have to know this material, but your principles may not have the same numbers. So be careful to use the list of principles or theorems that goes with your course. That is today's Daily Dose of Math. Please subscribe and share and hit that thumbs up button.